Number 36. Well, we could let u be something in here, but we really don't need to. Something squared, that would be just x minus x over 1 over x squared times itself, which would be x squared, and x times x 1 over x squared is just 1 over x, and that would be minus. And then this one would be also a minus, so that'd be minus 2 of those. And then 1 over x squared and 1 over x squared, both minus, multiply to be plus 1 over x to the fourth. So this is just the integral of x squared minus 2 over x plus 1 over x to the fourth. So the integral of x squared is 1/3 x to the 3. Integral of 1 over x is ln x, so we got minus 2 ln absolute value of x. And x to the minus 4 increased by 1, it'd be minus 3 divided by minus 3, so it'd be minus 1/3 x to the minus 3 plus c. And we could write this as 1 over 3x cubed. That's that one. Secant squared is the derivative of tangent, so I think I'm going to let u equal the tangent of theta, so that du equals secant squared theta d theta, divided by the secant squared du over. And so I have the integral secant squared theta, tangent is u to the 7th, and d theta is du over secant squared theta. So I get the integral of u to the 7th du, which increased to be 8, so it'd be 1/8 u to the 8th plus c, changing back to what we had, so it'd be 1/8 tangent of theta to the 8th plus c. Okay, the next one. This one's a little trickier. So 2 is e to the ln 2. That's 2 to the x, which is e to the x ln 2. So this is the integral of e to the x ln 2 times e to the 4x dx, which is the integral of e. We would add these, so we get x ln x ln 2 plus 4x dx. So if I let u equal x ln 2 plus 4x, then du would be, if x is times something, the derivative is just ln 2, and the derivative of this is just a 4 dx. So I'm going to replace dx with du over ln 2 plus 4. So I have the integral of e to the u du over ln 2 plus 4. This comes out. And the integral of e to the u is e to the u. Changing back, it'd be 1 over ln 2 plus 4 e to the x ln2 plus 4x. Well, that e to the x ln2 plus 4x is what we originally had. So this could, plus c, which could be written as 1 over ln2 plus 4, 2 to the x e to the 4x plus c. We could have left it here. All right, the next one. Well, this is, you don't have to make this complicated. This can split up into the integral of 7 dx minus the integral of e to the 10x dx. The integral of 7 is 7x minus the integral of e to the 10x is 1/10 e to the 10x. And this one. This one isn't so easy. We're going to split this one up into the integral of x over square root of 4 minus x squared dx plus the integral of 5 over square root of 4 minus x squared dx. And for this one, we're going to let u equal 4 minus x squared. So du would be minus 2x dx, and so I divide by minus 2x to find out what to put in for dx. So this one becomes the integral of, integral of x over the square root of u, and dx is du over minus 2x. The x's cancel. That's why I did that one on this way. And so that's going to become the integral of u to the minus 1/2, and the minus 2 comes out as a minus 1/2 out here, du. This one, not so easy. This one doesn't have an x to cancel, so now I'm going to go for the one that has 1 minus u something squared. That's the inverse secant, arc secant derivative. So I'm going to take the 5 out of the numerator, and I'm going to factor the square root of 4 out, which is 2. So this one's going to turn into 5 over 2 integral 1 over, if I take a 4 out of 4 as a 2 out, that's going to be 1 minus x over 2 squared. Because taking a 4 out of this make it 1/4 x squared, which is the same as x over 2 squared. dx, and I'm going to let u be x over 2, so du equals 1/2 dx. So the 2 would go over here, multiply by 2, and so this becomes, this is a different u than the u over here, so I got to be careful here, plus 5/2 integral of 1 over square root of 1 minus this u, maybe I should call this w, and so this would be w squared dw times a 2. That's what I put in for the dx. Okay, this 2 cancels here. And this becomes, raise that by 1, it'd be plus 1/2, divided by 1/2, which makes it times 2, so I get minus 1/2 times 2 u to the 1/2 plus these 2's cancel, so I get a 5. The integral of this is sine inverse of w plus c. So this becomes, the 2's cancel, minus the square root of this u was 4 minus x squared plus 5 sine inverse of w, which was x over 2. $57. Well, several people wanted to let u equal e to the x, so du would be e to the x dx, and so the e to the x would come under the du. And that works fine. And actually kind of makes this not too difficult to do. So this would become the integral of u times u squared plus 1 quantity cubed, and dx becomes du over u, and these cancel. And if I cube this, I get the integral of u squared plus 1 cubed is going to be u to the 6th plus 3u to the 4th plus 3u squared plus 1. Using the binomial theorem, if you don't get that, do u squared minus a plus 1 times u squared plus 1. Get that answer and take that times u squared plus 1, and you should end up with that. So the integral of this would be, one more than that is 7, so it would be 1/7 u to the 7th plus 4 goes to 5, 3/5 u to the 5th plus u to the 3rd divided by 3, so it's u to the 3rd plus u plus c, which would be 1/7 e to the x to the 7th, which e to the 7x plus 3/5 e to the x to the 5th is the 5x plus e to the 3x plus e to the x plus c. That's different than I did it in one of the classes, but comes out the same answer. This one, I think the derivative of that is going to be a 3x minus 1. So I'm just going to let u equal 9 minus 2x plus 3x squared. Du is minus 2 plus 6x dx. So I divide, and I'm going to get du over, and I said there was something here. There's a 2 of both of these, so I'm going to take out the 2, and it's going to be 3x minus 1. And there's my 3x minus 1. So, sorry, I didn't show that there. I can take a minus 2 out of this, and I get this. So, this becomes the integral of 3x minus 1 over u. That's what I let u be. And dx is du over 2 times 3x minus 1. And so the 2 can come out, and I got 1/2 integral of 1 over u du, which is 1/2 ln of absolute value of u plus c, which is going to be 1/2 ln of 9 minus 2x plus 3x squared plus c. Now this one, I saw some people splitting this up, but I think I would just let u equal 4 ln x plus 5. The plus 5 isn't a big deal when you're doing the derivative. Du would be 4, the derivative of ln x is 1 over x dx. So dx would equal x du over 4. And so this would become the integral of u over x times dx, which is x du over 4. The x's cancel. The 4 can come out as a fourth. Integral of u du, which is 1/4. That would go to 1/2 u squared plus c. So we got 1/8. 4 ln x plus 5 squared plus c. 1/8 times the 4 would be 1/2, but it'd be 5/8. No, you can't even multiply it in because that's squared. So that's where I'd leave it at. On this one, I saw people doing double substitutions, whatever, but I think the derivative of this is pretty sweet. Let's take a look at that. If I let u equal ln of x, then du would be the derivative of this, which would be 1 over ln x times the derivative of the inside, which is 1 over x dx. So these are both in the denominator, so if I solve for dx, it becomes ln x times the other x times du is what I'm going to replace dx with. And notice that. Look a lot alike. So this is going to be the integral of u, and du is x ln x du. I mean, dx is x ln x du over that x ln x. And poop, poop. Integral of u is 1/2 u squared plus c, and u was ln of x. And the final one. Nope, is that the final one? Yes. Okay, final one I'm going to do on this one. So I'm going to say let u be the t minus 3, and so du would be dt. Not very interesting there. Nothing's going to cancel, so I'm going to have some stuff left. I'm going to have to replace the t, though. Well, if I solve for t here, it'd be u plus 3. And so that's what I'm going to use. So I'm going to get the integral of u plus 3 squared times the square root of u, which is u to the 1/2, and du is dt, so just that. So I'm going to square that. Just showing you that's going to be u squared plus 6u plus 9 if I multiply that all out. So I'm going to have that times u to the 1/2. So I'm going to have the integral of u squared times u to the 1/2. That's, I add the power, so 2 plus 1/2 4 halves plus a half is 5 halves, plus 6 u to the 1, which is 2 halves, plus 1 half is u to the 3 halves, plus 9 u to the 1 half du, which integrated is 1 more than 5 halves is 7 halves, so it's 2 sevenths u to the 7 halves plus 6, 1 more than 3 halves is 5 halves, 2 fifths u to the 5 halves plus 1 more than 1 half is 3 halves, so 9 times 2 thirds u to the 3 halves plus c, and then going back to t, so this is going to be 2 sevenths t minus 3 to the 7 halves plus 12 fifths t minus 3 to the 5 halves plus 3 goes into 9, 3 6 t minus 3 to the 3 halves plus c.